Hello again. Today we are looking at 9.3 for math today, where we are looking at multiplication, division, number stories using mental math. We are going to be able to solve number stories using mental math. This is part of our algebraic thinking standards of being able to solve real-world problems. And this is something that we need to be able to do in the real world because when we go to stores or we want to buy things, most of the time it's not always just basic facts. A lot of times it's extended facts, and that's what we're working on today. And we want to be able to do that in our brain, right? In our head. We want to be able to do that without having to write it all out. Think about Mr. Fleming. He wants to buy Indianapolis 500 race tickets when it comes back to town, and they cost $75 each. Well, if we have 5 people going with us, he should be able to figure that out in his head. And today we're going to look at some strategies of how he could be able to do this. Now, why do we want to be able to solve mental math problems? Well, because mental math is something that is simple, that we don't have to work out. We don't have to write all the numbers out. It's more efficient, something I can do in my brain without having to write all these things down. I already know it. And it's something that helps us be able to, when we have a larger problem, be able to use the mental math to help us solve the larger problems, which is what we're doing today. Now, today we have some extra special pages in our workbook. Before we have the actual worksheet for us, there is these 2 pages that make this map of North America, and it shows different types of birds that live here. And it has numbers that show how much they can weigh. So like the snowy owl can weigh the smallest being 2 kilograms, the largest being 3 kilograms. Or this house sparrow being 25 grams all the way up to 40 grams. Okay, and so there's lots of different birds here that we can look at. So what I'm going to be modeling for you right now is finding the mass of 6 12-gram black-capped chickadees. So that is right here on our map. And I already know how much it weighs, so I don't have to look at the map to find out the weight because I already know it weighs 12 grams. And I know that I'm looking at 6 of them. And so it says when I'm trying to figure out 6 12-gram ones, that means I can picture 6 chickadees here, 6 of these birds, and they each weigh 12. Well, that means I'm trying to solve 6 times 12. That's the actual question here. What is 6 times 12? Well, I don't really know that in my brain, but we have learned something that I can use to figure that out. And we've learned the break apart strategy, right? Where we take 6 times 12. Now I know that 12 is really 10 plus 2. So I would multiply like this. 6 times 10 is 60. And then 6 times 2 is 12. And then I would add these 2 up. So 60 plus 12 is, write it down, 0 plus 2 is 2. 6 plus 1 is 7. So my answer is 72. 6 times 12 is 72, and this is in grams. Now, this is something that we worked out. This isn't really using mental math. I had to use 6 times 10. That was mental math. And 6 times 2, that was mental math. So if I can do that without having to work it out and actually draw the boxes, that would be the whole thing using mental math. So let's try that. If I solve this problem of 6 times 12 and thought in my brain automatically, well, I don't know 6 times 12, but I know 6 times 10. 6 times 10 is 60. And I know I have 2 more for each chickadee, 2 more grams for each chickadee. Well, that would look like this. If I have 6 chickadees, each one weighed 10, but now I'm making it 12. So instead of being 10, I'm adding 2 to each one, which means if that was 6 times 10 chickadees, now I'm doing 6 times 2 extra grams for each one. So that would be 6 times 2, which equals 12. And in my brain, I can say, well, 60 plus 12, 0 plus 2 is 2, 6 plus 1 is 7. So that would be 72. So I don't have to draw the box out and separate it like this. I can really do that in my brain. And think, okay, 6 times 12, the next closest one I know is 6 times 10. That's the helper fact. To get from 10 to 12, that's 2. So 6 times 2 is 12. Add those up. Okay, so if you need to still use the break apart strategy, that's completely fine. But I'm going to challenge you to see if you can try this way first, where you just think in your brain first, and then check it with the break apart strategy. That would be good to help you be able to gain that fact power, to be able to see, am I really understanding this? Okay. So in order to help practice this, we have multiplication top it up to 1,000. This has you multiplying 2-digit numbers. This is going to help you with the adding the 0, right, where it ends in 0. If you want to try a different multiplication top it, that's fine too. And so that you can try different types. You can also get on Excel and just practice multiplication today if you would like. Today is really about just gaining that fact power and being able to think about those basic facts to help you solve larger facts. And then your work today is you're going to work out this paper in your book, in your Student Math Journal, and you're going to use the map. When in your book it's on 2 different pages and it's side to side on page 207 and 278. You're going to use those pages to help you solve these problems. Now, on page 281 in your Student Math Journal, number 1, you don't have to be able to use this map. On number 2 and number 3, though, you will have to use the map. Number 1, it already tells you. It says the mass of 1 American white pelican is about 8 kilograms. What is the mass of 16 8-kilogram pelicans? So that's where, again, you can work it out. Here, maybe try 8 times 10 and then go up from there. You can decide how you want to try to do that mentally, and then you can work it out using the break apart. But here it says 1 blue jay has a mass of about 75 grams. What bird could have about the same mass as 6 75-gram blue jays? So you're going to have to be able to multiply what is 6 times 75 and then find the bird that would be the same. So you need to be able to work it out, and then your answer should actually be the bird's name of the other bird that weighs about the same. Same thing here. It says 1 house sparrow has a mass of 35 grams. How many blue-crowned motmots together would weigh about the same as 5 35-gram sparrows? So you already know that the 1 is 35, so you want to figure out what is 5 times 35, and then you want to find out how many of these blue-crowned motmots would equal the same as 5 times 35. So that's where you're going to, again, need to use this paper. When you are done, I want you to please fill out the Flipgrid and explain your thinking of how you solved number 1. Okay, so number 1, again, was the one where you didn't have to use this, that it already told you all the things here. So how did you figure out 8 times 16? I want to know, what was your thinking? I want you to explain that to me here, that you did on your paper. I want you to explain that to me on the Flipgrid. Okay, so this is a lot today. If you have any questions, we will be going over that during our Google Meet. And if you want to meet just me and you, remember, we can always do that too. Just message me and say, Mrs. Fleming, I need help, and we can work it out together. All right, happy working. Have a great day.